once again. So this is the last video for chapter 1, frequency domain. So in the definition relations we end up with new parameters introduced, and there's new terms that we use here. These are the impedance and admittances. So that's the definition relation in frequency domain of an inductor, and the parameter that we see here is j omega L. That's a complex number. This is not something that we faced already in time domain. So that's new parameter is called a special name for it, and it is called impedance. This impedance is a complex number, of course. So you might call this parameter is the ratio between V and I phasors. So V over I gives you impedance. If you write it I over V, so it is called, that means the inverse of this impedance, which is Y, and this is a special name for it. It is called admittance. So you can compare it with the resistor. If you consider resistor, resistance of which the dimension is ohms, and the inverse of R is conductance, dimension is Siemens. So that is the impedance corresponding to the resistance, and this is the admittance corresponds to the conductance. So similarly, for the capacitor, we can say that the impedance is equal to 1 over j omega c. That means V over I ratio is equal to this. I over V ratio is equal to this, j omega c. That is the admittance. So apart from this terminology, the another things that we use is reactance, the imaginary part of impedance. Later on we are going to say this. Some of the impedances has got real part as well. In here, this impedance is here imaginary part only, but there could be some impedances which includes the real part of it. So in this case, the imaginary part is called reactance. If there is an admittance, real part of it is conductance, imaginary part of it is susceptance. You don't have to memorize these terminology, but you've got to know the impedance admittance guaranteed. But you don't have to memorize those. Just remember it in case you might see it in a book. That is a short video that we used. So we end the chapter 1 now.